Now let us start with the new chapter, that is trigonometry. Trigonometry is made up of three words, that is trigonometry. So tri means three, gon means sides, and metry means measurement. That are Greek words which are used here. So trigonometry is the study of relationship relationships between sides and angles of a right triangle, right angled triangle. So here in this chapter we will be talking only about right angled triangles. Whether it is said or not, it will be a right angled triangle. Now let us see it. So now this is ABC, a right angled triangle with sides AB, BC and AC. And angle B is 90 degrees, so opposite of angle B is called hypotenuse. Opposite side of angle B is called hypotenuse. The angle which is given, that is angle A if we are talking, so AB is my base and BC will be my perpendicular or opposite side. And AB will be my base. As BA is touching angle A, so it will be adjacent side or base. Many people talk it as base, many say adjacent side. Both are correct. And here short forms will be used. So for perpendicular P, hypotenuse H, and adjacent side it will be B. Now let us see the same relation for angle C also. So ABC, so angle B is 90, so opposite side will be my hypotenuse, and now BC will be my adjacent side and AB will be my perpendicular or opposite side. Now to remember here the formulas of sin theta, tan theta, cos theta, we have a technique. Pandit Badri Prasad हर बोले सोना चांदी तोले. Here we have to take the first letter only of each one. So as Sona means sine, and that will be P upon H, that is perpendicular upon hypotenuse. Then cos theta will be B upon H, that is Badri's B and hers H. And same way tan theta will be P upon B. Prasad upon Bhole, B. Now three more relations are there, that is cosec theta, which is reverse of sin theta. So hypotenuse upon perpendicular. Now then comes sec theta, which is reverse of cos theta, that is hypotenuse upon base, and cot theta, which is reverse of tan theta, so B upon P. Now let us discuss first exercise. Question 1 says find sin A, cos A, sin C, cos C here. And two sides are given AB and BC. So first, to find the third side or the hypotenuse, we have to use Pythagoras theorem. And Pythagoras theorem is AC square equal to AB square plus BC square. So now AC I don't know. So AB is 24 square plus 7 square. So that will be 576 plus 49. So that will be 625, which is equal to 25 square. So AC is 25. Now all the three sides are known. So sin theta or sin A will be opposite upon hypotenuse. So that is BC upon AC. So that will be 7 upon 25. Opposite side will be BC and adjacent side will be BA and hypotenuse will be 25. So P upon H. So that will be 7 upon 25. Now cos A will be base or adjacent upon hypotenuse. So that is 24 by 25. Now B1, in B case I am given sin C. So sin C's opposite side will be BA upon AC. So P by H again, so 24 upon 25, and cos C will be B by H. So that will be 7 by 25. Now question 2 says find tan P minus cos R. I am given two sides, that is hypotenuse is given and perpendicular is given, base is not given. So again I have to use the Pythagoras theorem to get the base first or the adjacent side first. So again I can say PR square equal to PQ square plus QR square. So 13 square will be 12 square plus QR square. So 169, QR square will be 169 minus 144. So that will be 25. That is QR equal to 5. So now third side I got. Now I have to find tan P. Tan means opposite upon base. So using the technique Badri Prasad Har Har Bole. So tan P will be P upon B. So the cot R will be B upon P. Opposite upon tan P will be P. So opposite to P is 5. So 5 centimeter, that is 5 upon base is 12. And cot R will be cot R. Now base is 5. So base will be 5 upon 12. So they have asked us tan P minus cot R. So that will be 5 upon 12 minus 5 upon 12. So I will get 5 upon 12 minus 5 upon 12. So that will be equal to 0. Now third one, it is given sin A equal to 3 by 4, cos A and tan A I have to find. So sin A. So sin A is nothing but opposite upon hypotenuse. So I am putting the values BC as 3 and hypotenuse as 4. So AC square will be equal to AB square plus BC square. So 4 square equal to AB square plus 3 square. So AB square will be 16 minus 9. So that will be 7. So AB equal to root 7. So I got all the values. Now cos. So cos A equal to base upon hypotenuse. So that will be root 7 and tan A is perpendicular upon base. So cos A will be root 7 by 4 and tan A will be equal to 3 by root 7. Now fourth one says 15 cot A equal to 8, find sin A and sec A. So here see cot means base upon hypotenuse. Oh sorry, base upon perpendicular. So here base is 8 and perpendicular will be 15. So using Pythagoras theorem, AC square equal to AB square plus BC square. So that will be 8 square plus 15 square. So 8 square means 64 plus 225. 289. So that will be equal to 17 square. So AC equal to 17. Now all the three sides we have got. Now cot A will be equal to 8 upon 15. Now I have to find sin A. So sin A equal to opposite, that is perpendicular upon hypotenuse. So that is 15 upon 17 and sec A. Hypotenuse, that will be opposite of cos. So hypotenuse upon base. Hypotenuse upon base. So that will be 17 upon 8. Now fifth one, he has given us sec theta equal to 13 by 12. Find all other relations. So now here sec means hypotenuse upon base. So hypotenuse and base I have kept. So using Pythagoras theorem, that is AC square equal to AB square plus BC square. So 13 square equal to 12 square plus BC square. So BC square will be 169 minus 144, that is equal to 25. That is equal to 5 square. So BC I have got 5. Now sin theta will be equal to perpendicular upon hypotenuse. So that will be pi upon 13. So cos theta will be base upon hypotenuse. So that will be 12 upon 13. Tan theta perpendicular upon base. So that will be pi upon 12. Now cosec theta will be opposite of sine. So h by p. So 13 by 5. And cot theta will be opposite of tan theta. So base upon perpendicular. So 12 upon 5. So all the relations are achieved. Now, sixth one, he says angle A and B are acute angles, cos A equal to cos B. Then prove that angle A equal to angle B. Let us assume triangle ABC be a triangle such that CD is perpendicular to AB cos A equal to cos B. That is given. So cos A AD upon AC equal to cos B. So cos B will be BD upon BC. So AD and BD are equal upon BD equal to AC upon BC. Let this be K, that is constant. Now AD equal to KBD, so 1, and AC equal to KBC, so 2. Now using Pythagoras theorem in triangle CAD and triangle CBD, CD square equal to BC square minus BD square, that is third, and CD square equal to AC square minus AD square, that is fourth. LHS of 3 and 4 are equal, so BC square minus AD square equal to AC square minus AD square. So in 1 and 2 I have got the values, so let me put BC square minus BD square equal to AC KBC square minus AD is KBD whole square. So that will be K square BC square minus BD square. Now both sides I have got BC square minus BD square. So if I can cut that, so let me cut that. So I can say K square equal to 1. So therefore AC equal to BC. So if AC equal to BC, then angle A equal to angle B. Opposite angles of equal side are equal. Now seventh one is cot theta is given as 7 upon A, 7 upon 8, and I am asked first 1 plus sin theta into 1 minus sin theta whole upon 1 plus cos theta into 1 minus cos theta. And second one, it is asked cot square theta. Now already I have done the Pythagoras theorem and I have shown that the third side I am getting as root 113. So the first one will be equal to, so A minus B whole square formula I have used, so 1 minus sine square upon 1 minus cos square theta. Now I need sine theta's value and cos theta's value. So sine theta will be 8 upon root 113 and sine square theta will be 64 by 113 and cos theta equal to 7 by root 113. So cos square theta will be 49 upon 113. So now putting the values, 1 minus sine square theta upon 1 minus cos square theta will be equal to 1 minus 64 by 113 whole upon 1 minus 49 upon 113. Now doing the LCM in numerator and denominator, so 113 minus 64 upon 113 whole upon 113 minus 49 upon 113. So denominator gets cancelled of both, so I get 49 upon 64. Now cot square theta 10. So base upon perpendicular. So base is 7 upon 8. So 7 square upon 8 square. So 49 upon 64. Now eighth one is 3 cot A equal to 4. So cot A equal to 4 by 3 and find 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A or not. So here also first I have used the Pythagoras theorem and find the third side using the given values. Now tan A will be opposite upon base. So 3 by 4. So 10 square A will be 9 by 16. Sin A will be 3 by 5 perpendicular upon hypotenuse. So 3 by 5. So sin square A will be 9 by 25 and cos A will be based upon hypotenuse. So 4 by 5. So cos square A equal to 16 upon 25. Now let us put the values LHS. So 1 minus tan square A upon 1 plus tan square A equal to 1 minus 9 upon 16 whole upon 1 plus 9 upon 16. So doing LCM in numerator and denominator, 16 minus 9 upon 16, 16 plus 9 upon 16. So 16, 16 cancel, 6, 7 upon 25 I got. Now let us solve RHS. So that will be cos square A minus sin square A. So cos square A is 16 upon 25 minus 9 upon 25. So LCM will be 25. So 7 upon 25. So therefore LHS equal to RHS. So I can say 1 minus tan square A upon 1 plus tan square A equal to cos square A minus sin square A. Now ninth sum is tan A equal to 1 upon root 3. Find sin A cos C plus cos A sin C. Second one is cos A cos C minus sin A sin C. So again I have done the hypotenuse. First I have found that is AC is 2. Now sin A will be opposite upon hypotenuse. So 1 by 2 cos cos A will be root 3 by 2 sin C. So sin C equal to root 3 by 2 and cos C equal to 1 by 2. So now finding the values of first one, that is sin A cos C plus cos A sin C. So that will be equal to 1 by 2 into 1 by 2 plus root 3 by 2 into root 3 by 2. So that will be equal to 1 by 4 plus 3 by 4. So that is 4 by 4. So that is equal to 1. Now second one, cos A cos C minus sin A sin C. So putting the values again, so cos A is root 3 by 2, cos C is 1 by 2 minus 1 by 2 into root 3 by 2. So that will be root 3 by 4 minus root 3 by 4. So that will be equal to 0. Now 10th sum is PR plus QR is given 25 and PQ equal to 5. So let us take QR equal to X first. one side is given as pi and sum of other two sides is 25. So let QR equal to x centimeter. So therefore PR will be 25 minus QR, that is 25 minus x. So now using Pythagoras theorem, PR square equal to PQ square plus QR square. So PR is 25 minus x whole square equal to PQ is 5. So 5 square plus x square. So 25 square will be 625 minus 50x plus x square equal to 25 plus x square. So x square got cancelled. 625 minus 25 equal to 50x. So x equal to 600 upon 50. So 0 cancel, 5 12s. So x equal to 12 centimeter. So if x is 12 centimeter, so QR will be 12 centimeters. So PR equal to 25 minus 12. So that will be 13 centimeter. Now he is asking us to find sin P. So sin P will be opposite. So QR upon PR. So that will be 12 upon 30. Then cos P equal to PQ upon PR. PQ upon PR. So PQ is 5 upon 13. And tan P equal to QR upon PQ. So 12 upon 5. Now 11th sum is the value of tan A is always less than 1. Just say true or false and justify your answer. False, because in triangle M and C, angle N equal to 90 degree, MN equal to 3 centimeter, NC equal to 4 centimeter, and MC equal to 5 centimeter. 10 10m will be 4 by 3, which is more than, greater than 1 or more than 1. Whatever you write, both are correct. Second one is sec A equal to 12 by 5 for some value of angle A. True. Let triangle M and C be there with angle N equal to 90 degree, MC equal to 12, MB equal to 5. So MC square will be equal to MN square plus NC square. So 12 square equal to 5 square plus NC square. So 144, MC square will be 144 minus 25. So that is 119 K square. So such triangle is possible, therefore it is true. Third one, cos A is the abbreviation used for the cosecant of angle A. So that is true, as we write short form of cosecant as cos A. So now fourth one is cot A. is the product of cot and A. False, as A is not the product of cot and A, but cot A means angle, cot of angle A. So sin theta equal to 4 by 3 for some angle theta. This is also false, as sin theta can't be more than 1. So sin theta equal to opposite upon hypotenuse. Hypotenuse is the longest side of the. So if the longest side is 3, the smallest side can't be 4. Therefore sin theta cannot be greater than 1. Today we are going to learn some important relations of sin theta, tan theta and cos theta. So now if I take my left hand, so my thumb will be 0 degree, my first finger will be 30 degree, 45, 60 and the smallest finger will be 90 degree. For sin theta, the formula is square root of fingers below upon 2. So for example, if I want to find sin 90, so that will be fingers below 90 degrees. So my smallest finger is 90, so fingers below that is 4. So root of 4 upon 2. So that will be 2 by 2, so which is equal to 1. Then if I say sin 30, so fingers below, so only one thumb, so root 1 upon 2, so that will be 1 by 2. Same way I can do for sin 60, so 3 root 3 upon 2. 3 fingers are below 60, so root 3 by 2. So root sin 45 will be root 2 upon 2 upon 2. That will be 1 root 2 upon root 2 into root 2. So 1 root 2 get cancelled, so 1 by root 2. And to find sin 0, I will fingers below. So that is no fingers, so 0 by 2. Root 0 by 2. So that will be 0 by 2. 0. So this is an easy way to remember the table of sin theta. Now same way going for cos theta, so we have to consider the fingers above. So now if I fingers above, so suppose if we are find cos 0, so cos 0 will be 4 fingers are above thumb. So root 4 upon 2. So that will be 2 by 2, that is 1. Then cos 30 degree will be equal to cos 3 by 2. Cos 60 will be root 1 upon 2. So 1 by 2. Cos 45 or 90, if I take, so 0 fingers above. So 0 upon root 0 upon 2. So that is 0. Cos 45, 2 fingers are above, so root 2 upon 2. So that will be equal to 1 by root 2. Now for tan theta, it is square root of fingers below upon square root of fingers above. So sine upon cos I am doing. So tan 0 will be how many fingers below? So 0. So root 0 upon fingers above. So 4 fingers. So root 4. So 0 by 2. So that is 0. Now tan 30 will be root 1 upon root 3. So 1 upon root 3. Same way tan 45 will be 2 above 2 below. So root 2 upon root 2. So that is 1. Tan 60, one finger is above, below are 3, so root 3 by root 1. So root 3. Tan 90, if I do, root below are 4, so root 4 upon 0. Above, so 0. So that will be 2 upon 0, so not defined. Now for cosec I have to just reverse sign. For sec I have to reverse cos, and for cot I have to reverse tan theta. So whole table is done. Now coming to exercise 8.2, question 1, first one says evaluate sine 60 cos 30 degree plus sine 30 degree cos 60 degree. So we will be using the sine theta and cos theta table. So sine 30 equal to 1 by 2. Sine 60 will be root 3 by 2. Cos 30 will be equal to root 3 by 2. And cos 60 will be 1 by 2. So now putting the values. So I will get sine 60. So root 3 by 2 into cos 30. Cos 30 is root 3 by 2 plus sine 30 is 1 by 2 into cos 60. So 1 by 2. So that will be 3 upon 4 plus 1 upon 4. So that will be 4 by 4. That is equal to 1. Now second one is 2 tan square 45 degree plus cos square 30 degree minus sine square 60 degree. So again sine 60 equal to root 3 by 2, cos 30 will be root 3 by 2, and tan 45 is 1. So putting values, so 2 tan square, so 2 into 1 whole square plus root 3 by 2 whole square minus root 3 by 2 whole square. So root 3 by 2 whole square, root 3 by 2 whole square got cancelled, so answer is 2. Then third one is cos 45 upon sec 30 plus cosec 30. So putting the values directly, 1 by root 2 whole upon sec means 2 by root 3 plus 2 by 2. So that will be 1 upon root 2 plus 2 plus 2 root 3 upon root 3. So if I multiply with reciprocal, so I will get 1 upon root 2, that is into root 3 upon 2 plus 2 root 3. So root 3 upon root 2 into 2 plus 2 root 3. So that will be root 3 upon 2 root 2 plus 2 root 6. if I multiply by, to rationalize the denominator, I am multiplying it with coincidence. So into 2 root 2 minus 2 root 6 upon 2 root 2 minus 2 root 6. So root 3 into 2 root 2 minus 2 root 6 upon 2 root 2 whole square minus 2 root 6 whole square. So that will give me as 2 root 6 minus 2 root 18. So 18 upon 2, for 2 square will be 4. So 4 into 2 minus 4 into 6. So this will be 2 root 6. If I take 9 common out of 18, so that will be 6 root 2. So 3 root 2 will be inside. So 3 2s are 6. So 6 root 2 upon 8 minus 16. So minus 16 came. So that will be 2 root 6 plus 3 root 2 upon 16. The negative sign I have taken up. Now I am taking 2 common from both. So 3 root 2 minus root 6 upon 8. Now fourth one, sine 30 plus tan 45 minus cosec 60 whole upon sec 30 plus cos 60 plus cot 45. So putting the values, 1 upon 2 plus 1 minus 2 upon root 3 whole upon 2 by root 3 plus 1 upon 2 plus 1. Now doing LCM in the numerator and denominator. So 2 root 3. So root 3 plus 2 root 3 minus 4 whole upon, again the denominator is 2 root 3. So 4 plus root 3 plus 2 root 3. So now denominator got cancelled. So 3 root 3 minus 4 upon 4 plus 3 root 3. Again multiplying with the opposite sign to rationalize the denominator. So root 3 minus into 4 minus 3 root 3 minus 4 into 4 minus 3 root 3 upon 4 whole square minus 3 root 3 whole square. So that will be 12 root 3 minus 9 into 3. So 27 minus 16 plus 12 root 3 whole upon minus 11. So that will be 24 root 3 minus 43 upon minus 11. Now minus sign I am taking up. So 43 minus 24 root 3 upon 11. Fifth one, 5 cos square 60 degree plus 4 sec square 30 degree minus tan square 45 degree whole upon sin square 30 degree plus cos square 30 degree. So that will be 5 into 1 by 2 whole square plus 4 into 2 by root 3 whole square minus 1 whole upon 1 upon 2 whole square plus root 3 by 2 whole square. So this will come as pi into 5 by 4 plus 4 4s are 16, 16 upon root 3. Or I can write 4 into 4 root 3 minus 1 upon 1 by 4 plus 3 by 4. 5 upon 4 plus 16 by 3 minus 1 whole upon 4 by 4. So that is 1. So now LCM is 12 in the numerator. So 15 plus 64 minus 12 whole upon 1. So that will be 67 upon 12. Now question 2, first one says 2 tan 30 whole upon 1 plus tan square 30 degree will be equal to sin 60, cos 60, tan 60 or sin 30. You have to find the correct alternative. So 2 tan 30 upon 1 plus tan square 30, let us put the value and check. So that will be 2 into tan 30 will be 1 upon root 3. 1 plus 1 by root 3 whole square. So that will be 2 by root 3 whole upon 1 plus 1 by 3. So 2 by root 3 whole upon 3 plus 1 by 3. So now if I bring them in the normal form, 2 upon root 3 into 3 by 4. So 2 ones are 2 twos are root 3 ones are root 3 twos are. 3 by 2 root 3. I will be left out. So 3 if I cut as root 3 into root 3, so root 3 cut. So root 3 by 2. So root 3 by 2 is sin 60. Then second one, 1 minus tan square 45 degree whole upon 1 plus tan square 45 degree. Options are tan 90 degree, B 1, C sin 45 degree, D will be 0. So let us check that also. 1 minus tan square 45 degree. So that will be 1 square, 1 plus 1 square. So that is 1 minus 1 upon 2. So 0 by 2. So that is 0. D is correct. Now third one, it says sin 2a equal to 2 sin a is true when a is 0 degree, 30 degree, 45 degree, or D is 60 degree. So sin 2a equal to 2 sin a. So LHS will be sin 2a. So 0 degree if I do, so sin 2 into 0. So that will be 0. RHS will be 2 into sin. So 2 into sin 0. So 2 into 0. So that is 0. So therefore LHS equal to RHS. Fourth one says 2 tan 30 degree whole upon 1 minus tan square 30 degree is equal to, the options are cos 60, B is sin 60, C is tan 60 degree, D is sin 30 degree. So solving 2 tan 30 upon 1 minus tan square 30 degree. So 2 into tan 30 upon 1 minus tan square 30 degree will be equal to 2 into 1 by root 3 whole upon 1 minus 1 by root 3 whole square. So that will be 2 by root 3 upon 1 minus 1 upon 3. So 2 by root 3 into 3 upon 2. So 2 cancel. So root 3 will be my answer. So that is tan 60 degree. Now question 3 says tan A plus B equal to root 3, tan A minus B equal to 1 upon root 3. The A plus B is less than 0 and greater than or equal to 90. And also A is greater than B. So tan A plus B equal to root 3. So root 3. So tan 60 equal to root 3. So I can write tan 60 equal to tan A plus B. So A plus B equal to 60 degree. So that I am giving as one number. Now tan A minus B equal to 1 upon root 3. So again I can say that tan 30 degree equal to tan A minus B. So A minus B will be 30 degrees. So two number. So solving 1 and 2, A plus B equal to 60, A minus B equal to 30. So B cancel. So 2A equal to 90. So A is 45. A is 45 degree. Putting A equal to 45 in 1. So that was A plus B equal to 60 degree. So 45 plus B equal to 60. So therefore B equal to 60 minus 45, that is 15 degree. Now fourth question says sin A plus B equal to sin A plus sin B. And we have to say whether it is true or false. Let A equal to 60 degree, B equal to 30 degree. I am taking any two value and trying to solve it. So sin A plus B will be equal to sin 60 degree plus 30 degree. So that will be 90 degree. So sin 90 degree will be equal to 1. So LHS I have solved. Now let us solve RHS. So sin 60, sin A plus sin B. So that will be sin 60 degree plus sin 30 degree. So that is equal to sin 60 is root 3 by 2 plus sin 30 is 1 by 2. So root 3 plus 1 whole upon 2. So therefore LHS is not equal to RHS. Therefore it is false. Second one is the value of sin theta increases as theta increases. Here first I am taking sin 0 is 0, sin 30 is 1 by 2, sin 45 is 1 by root 2, sin 60 degree is root 3 by 2, and sin 90 equal to 1. So therefore value of sin theta increases as theta increases. As theta increases. So it is true. Now third one, the values of cos theta increases as theta increases. So here cos 0 will be 1, cos 30 degree will be root 3 by 2, cos 45 is 1 by root 2, and cos 60 will be 1 by 2, and cos 90 is 0. So therefore it is false, as value of cos theta is decreasing from cos 0 to cos 90. Fourth one is sin theta equal to cos theta for all values of theta. So to prove this, I can take sin 30 only, simple, theta is 30. So sin 30 will be 1 by 2 cos 30 degree equal to root 3 by 2. So therefore sin theta 30 is not equal to cos 30 degree. So therefore I can say it is false. Fifth one, cot A is not defined for A equal to 0 degree. So cot 0 will be equal to cos 0 upon sin 0. So cos 0 is 1 upon 0. So that is not defined. So therefore it is true. Now we are going to learn some of the tricks to remember some of the conversions. So for that, first I am drawing the figure. So like this you have to draw, and in the center I am writing 1. At one corner I am writing sine, cos. Here I will write cot, cosec, sec, and tan. Sine Sine and cosec I am opposite to each other. Cos and sec I am having opposite to each other. So cosec theta is equal to 1 upon sine theta. Same way sec and cosec are cos are there. So sec theta equal to 1 upon cos theta. Same way tan and cot are there. So cot theta equal to 1 upon tan theta. Now if I move like that, the arrow form to tan theta equal to sin theta upon cos theta. Sin theta will be equal to cos theta upon cot theta. Cos theta upon cos theta upon sin theta. So if I reverse it, so cos theta into sin theta upon cos theta. So cos theta got cancelled. Cos theta will be equal to cot theta upon cosec theta. If I clockwise I go, I will get one pattern of formula, that is cot theta will be equal to cosec theta upon sec theta. Is sec theta equal to tan theta upon sin theta. Now one doubt arises in my mind, if I instead of clockwise, if I start anti-clockwise, then so cot theta will be equal to cos theta upon sin theta. Both the ways you can move and you will get the correct formula. Here we can get the correct formulas also, that is sin square theta plus cos square theta equal to 1. Now I am drawing the hexagon again to show you how that sine square theta plus cos square theta is coming. So this is my hexagon which was shown there, and at the center it was written 1. So in the first triangle it was sine theta cos theta. So if I take that one triangle and I say sine square theta plus cos square theta will be 1. At the third vertex I am having 1, so that will be equal to 1. Then second triangle if I take, that was tan theta and sec theta. So tan square theta plus 1 equal to sec square theta. The third part was cosec and cot. So if I take that triangle, so 1 plus cot square theta equal to cosec square theta. All the three formulas I get from here. In an easy way I can remember them. Now exercise 8.3 question 1 says sin A, sec A and tan A in the terms of cot A. I have to find all these relations in term of cot A. So first sin A. So sin A means root of sine square A, root of sine square A. So now sine square I can write 1 upon cosec square, 1 upon cosec square A. So that root, because sine A equal to 1 upon cos A, cosec A. 1 upon cosec A. So now that I am again shifting as cosec square A, I am shifting as 1 upon 1 plus cot square A. Because just now we saw 1 plus cot square A equal to 1. That formula. Cot square A equal to cosec square A formula just now we saw. So that I am using here. So that will be 1 upon root of 1 plus cot square A. Then second one is sec A. Sec A. So that I can write as sec square A equal to 1 plus tan square A. So if I, so 1 plus tan square, instead of that I am writing 1 upon 1 plus cot square A. So that will be cot square A plus 1 upon cot square A. So if I do square root on both sides, so I will get sec A. So that will be root of cot square A plus 1 upon cot square A. So that will be root of cot square A plus 1 upon cot A. Third one is tan A. So tan A equal to 1 upon cot A, 1 upon cot A. So now second question says write all the other trigonometrical ratio of angle A in terms of sec A. So sine square A plus cos square A equal to 1. So sine square A will be 1 minus cos square A. So sine square A will be 1 minus 1 upon sec square A. So this will be equal to, because cos A equal to 1 upon sec A, that's why I have used this formula. Now that if I do LCM, so sec square A minus 1 upon sec square A. So sin A will be equal to root of sec square A minus 1 upon sec A. So I got sin in the form of sec. Now cos A will be 1 upon sec A. So directly I am getting that. Then tan A equal to sin A upon cos A. So in place of sin A, I can write the above one, that is root of sec square A minus 1 upon sec A whole upon 1 upon sec A. So that will be equal to, if I reverse and multiply, so I will get sec square A minus 1 root whole upon sec A into sec A upon 1. So sec A got cancelled, so I got equal to root of sec square A minus 1. Now cosec A equal to 1 upon sin A. So sin A already we have found, so that value I can directly keep 1 upon root of sec square A minus 1 whole upon sec A. So that will be equal to sec A upon whole upon sec square A minus 1 whole in square root. Now cot A equal to 1 upon tan A. So tan A already we have found. So 1 upon root of sec square A minus 1. Now question 3 says choose the correct alternative. Justify your answer. 9 sec square A minus 9 tan square A equal to. So first I am taking 9 common from both. So that 9 into 1. So answer will be my 9. Because sec square A equal to minus tan square A equal to 1. So the answer is 9. So option B is right. Now second one says 1 plus tan theta plus sec theta into 1 plus cot theta minus cosec theta equal to. So first I am converting everything in sine and cos. So 1 plus sine theta upon cos theta plus 1 upon cos theta into 1 plus cos theta upon sine theta minus 1 upon sine theta. Minus 1 upon sine theta. Now doing LCM. So LCM will be in the first bracket, it will be cos theta. So cos theta plus sin theta plus 1 in the numerator upon cos theta. Second bracket I am getting sin theta as denominator. So sin theta plus cos theta minus 1 whole upon sin theta. Now if I multiply that both, so see, if I consider sin theta plus cos theta as one unit, so cos theta plus sin theta whole square minus 1 whole square upon cos theta sin theta. So this will be equal to a square plus b square plus 2ab. So cos square theta plus sin square theta plus 2 sin theta cos theta minus 1 whole upon cos theta sin theta. But cos square theta plus sin square theta equal to 1. So I am putting that value there, 1 plus 2 sin theta cos theta minus 1 whole upon sin theta cos theta. So 1 and minus 1 got cancelled. So my final answer will be 2 sin theta cos theta upon sin theta cos theta. And numerator and denominator, sin theta and cos theta will get cancelled. So final answer will be 2. Now, next one is sec a plus tan a into 1 minus sin a. So first converting everything into sin cos. So 1 upon cos a plus sin a upon cos a into 1 minus sin a. So if I do LCM, so 1 plus sin a upon cos a into 1 minus sin a. So in the numerator I am having 1 plus sin a, 1 minus sin a. So that will be 1 minus sin square a whole upon cos a. Now I know that 1 minus sin square is cos a, cos square a. So cos square a upon cos a. So cos a got cancelled. So my answer will be cos a. Fourth one says 1 plus tan square a upon 1 plus cot square a. So 1 plus tan square a is sec square a and 1 plus cot square a is cosec square a. So now cosec square, sec square I can write 1 upon cos square a whole upon 1 upon sin square a. So if I reverse, I will get 1 upon cos square a into sin square a upon 1. So that is sin square a upon cos square a. So that is tan square a. Now, question fourth is prove the following. Cosec theta minus cot theta whole square equal to 1 minus cos theta upon 1 plus cos. So LHS I am starting solving. So whole square it is. So first I will be opening the I will be converting it into sin and cos. So 1 upon sin theta minus cos theta upon sin theta whole square. So now sin theta will be LCM. So 1 minus cos theta whole upon sin theta whole square. So that will be 1 minus cos theta whole square whole upon sin square. Now if I open the bracket of 1 minus cos theta, so it will be 1 minus cos theta into 1 minus cos theta upon sin square theta. And sin square theta I am writing as 1 minus cos square theta. So 1 minus cos theta into 1 minus cos theta upon a square minus b square. So a minus b, a plus b I am writing. So 1 minus cos theta, 1 plus cos theta. So 1 minus cos theta, 1 minus cos theta got cancelled. So that is RHS. Now second one is cos a upon 1 plus sin a plus 1 plus sin a upon cos a equal to 2 sec a. So again LHS I am taking. So now I have written LHS. Now I am doing first LCM there. So 1 plus sin a into cos a. So cos square a plus 1 plus sin a whole square. So that will be cos square a plus 1 plus 2 sin a plus sin square a whole upon 1 plus sin a into cos a. Now sin square plus cos square is 1. So 1 plus 1 will be 2. 2 plus 2 sin a upon cos a into 1 plus sin a. So if I take 2 common in the numerator, 1 plus sin a whole upon cos a into 1 plus sin a. So 1 plus sin a, 1 plus sin a I am cutting. So I got 2 upon cos a. So 2 upon cos a means 2 sec a. So 2 sec A, which is equal to RHS. Now, third one says tan theta whole upon 1 minus cot theta plus cot theta upon 1 minus tan theta equal to 1 plus sec theta cosec theta. So again LHS I am converting it into sine cos. So tan theta means sine theta upon cos theta minus 1 upon cos theta whole upon sine theta plus cot theta will be cos theta upon sine theta whole upon 1 minus sine theta upon cos theta. Now doing LCM in the both the denominators. So I will get sine theta upon cos theta whole upon sine theta minus cos theta whole upon sine theta plus cos theta upon sine theta whole upon cos theta minus sine theta whole upon cos theta. Now multiplying with the reverse, so sine theta upon cos theta into sine theta upon sine theta minus cos theta plus cos theta upon sine theta into cos theta upon cos theta minus sine theta. So sine theta into sine theta will be sine square theta. Now, if I multiply them, sine square theta upon cos theta into sine theta minus cos theta plus cos into cos will be cos square theta. So, now from here I am taking minus common so that I can write cos square theta upon sine theta into sine theta minus cos theta. So, now if I do, now I am again doing the LCM. So sine theta cos theta into sine theta minus cos theta. So I will get sine cube theta minus cos cube theta. So now using a cube minus b cube formula, sine theta minus cos theta into sine square theta plus cos square theta plus sine theta cos theta whole upon sine theta cos theta into sine theta minus cos theta. So sine theta minus cos theta got cancelled, the whole bracket. So sine square theta plus cos square theta will be 1. So 1 plus sine theta cos theta whole upon sine theta cos theta. So now if I write, if I make the denominator separate, so it will be sine theta cos theta upon sine theta cos theta plus 1 upon sine theta cos theta into 1 upon cos theta also I can write. So this got cancelled. So I got 1 plus cosec theta into sec theta. Now next is 1 plus sec a upon sec a equal to I have to prove. So LHS I am taking and solving it into sine and cos. So 1 plus 1 upon cos whole upon 1 upon cos. So LCM cos a plus 1 upon cos a into upon 1 upon cos a. So now multiplying with the inverse. So cos a plus 1 upon cos a into cos a upon 1 into cos a by 1. So cos A got cancelled. So that is coming as cos A plus 1 or 1 plus cos A whole upon 1 into. Now I am multiplying with minus. So 1 minus cos A upon 1 minus cos A. So 1 plus cos A into 1 minus cos A whole upon 1 minus cos A. So see, denominator of RHS I got. Now this will be 1 square minus cos square A. So 1 minus cos square A upon 1 minus cos A. So 1 minus cos square will be sin square. So that will be equal to sin square A upon 1 minus cos A. So I got RHS. Now fifth one, again it is asked to prove that. So, and I have to use the identity cosec square A equal to 1 plus cos square A. So first I am taking LHS, so that is cos A minus sin A plus 1 whole upon cos A plus sin A minus 1. Now I am dividing both with sin A. Numerator, so cos A upon sin A minus sin A upon sin A plus 1 upon sin A whole upon cos A upon sin A plus sin A upon sin A minus 1 upon sin A. So that will be equal to cos A minus 1 plus cosec A whole upon cot A plus 1 minus cosec A. That is equal to cot A plus cosec A minus 1. Now instead of minus 1, I am writing cosec square A minus cot square A. I have used the identity whole upon cot A minus cosec A plus 1 as it is I am keeping. So that will be equal to now cot A plus cosec A in one bracket minus cot A or cosec A minus cot A into another bracket cosec A plus cot A whole upon cot A minus cosec A plus 1. So now from in the numerator I am taking cot A plus cosec A common. So in bracket I will have 1 minus cosec A minus into minus will be plus, so plus cot A whole upon cot A minus cosec A plus 1. Now if you see the bracket is common, so I am cutting that, so I got cosec A, cot A plus cosec A. So that is equal to RHS. Now sixth one is root of 1 plus sin A upon 1 minus sin A equal to sec A plus tan A. So here I am multiplying LHS with conjugate. So LHS equal to 1 plus sin A upon 1 minus sin A. And multiplying with conjugate. So 1 plus sin A upon 1 minus sin A I am multiplying. 1 plus sin A upon 1 plus sin. So that will be root of 1 plus sin A whole square upon 1 minus sin square A. So that will be equal to root of 1 plus sin A whole square upon cos square. So that will be equal to, now if I remove the bracket, root, sorry, so I will get 1 plus sin A whole upon cos A. Now cos A I am splitting up. I am making the denominator below both of them. So 1 upon cos A plus sin A upon cos A. So 1 upon cos A will be sec A and sin A upon cos A will be tan A. So I got RHS. Now seventh one says sin theta minus 2 sin cube theta upon 2 cos cube theta minus cos theta equal to tan theta. So LHS, I am taking sin theta from the numerator common. So 1 minus 2 sin square theta whole upon cos theta I am taking common. So I will get 2 cos square theta minus 1. So now sin theta into sin square theta plus cos square theta minus 2 sin square theta. I have used the formula a square plus b square minus 2ab. Cos theta into 2 cos square theta minus sin square theta plus minus cos square theta. Instead of 1, I have written sin square theta plus cos square theta. Now, moving ahead, sin square theta and 2 sin square theta. So that will be cos square theta minus sin square theta. Now, in the denominator also, cos theta into 2 cos square theta minus cos square theta will be cos square theta. So cos square theta minus sin square theta. So now cos square theta minus sin square theta will get cancelled. So that is equal to sin theta upon cos theta, which is equal to tan theta, which is equal to RHS. Now eighth one says sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. Now I have taken the LHS. Now first I am using the formula A plus B whole square. So sin square A plus 2 sin A cosec A plus cosec square A plus, same way there also I am using the formula. So cos square A plus 2 cos A sec A plus sec square A. So now see, I got sin A and cosec A will get cancelled and cos A and sec A will get cancelled. So that I am cancelling. So 2 plus 2, that will be 4 plus sin square A plus cos square A will be 1. So that 1 I have written. Plus, now I am left with cos square A plus sec square A. So, this is equal to 5 plus 1 plus cot square A plus 1 plus tan square A. So that 5 plus 6 plus 7. So 7 plus cot square A plus tan square A. And that I got RHS. Now ninth one says cosec A minus sin A into sec A minus cos A equal to 1 upon tan A plus cot A. So LHS I have taken. Now I am writing cosec A minus sin A. That sin A I am converting into cosec A. So 1 upon cosec A, sec A minus 1 upon sec A. So now doing LCM. So I will get cosec square A minus 1 upon cosec A into sec square A minus 1 upon sec A. So that will be equal to now cot square A upon cosec A into tan square A upon sec A. So now cot square A I am converting, cosec A I am converting to sine. So sine A upon cot I have converted to tan. So upon tan square A whole upon into tan square A into cos A. So tan square A got cancelled. So sin A into cos A. Now RHS I am taking and solving it because now I can't solve LHS. 1 upon tan A plus cot A. So that will be 1 upon sin A upon cos A plus cos A upon sin A. Now doing the LCM in the denominator. So 1 upon sin square A plus cos square A upon sin A cos A. So sin square A plus cos square A will be 1. So sin A cos A upon 1. So therefore it is equal to sin A cos A. Now both I have got as sin A cos A. So LHS equal to RHS. Now last 10th one is 1 plus tan square A upon 1 plus cot square A equal to 1 minus tan A upon 1 minus cot A whole square equal to tan square A. Now LHS I have taken. Now 1 plus tan square A will be sec square A upon cosec square A. So sec square means 1 upon cos square and cosec means 1 upon sin square. So that will be sin square A upon cos square A. So that is tan square A. So first one I proved it is equal to tan square A. Now let us prove the second one. 1 minus tan A upon 1 minus cot A whole square. So that will be equal to 1 minus sin A upon cos A whole upon 1 minus cos A upon sin A whole square. Now this I am making the denominators in numerator and denominator. So cos A minus sin A whole upon cos A whole upon 1 sin A minus cos A whole upon sin A whole square. So that will be equal to cos A minus sin A whole square upon cos A cos square A into sine square A upon sin A minus cos A whole square. So, so that will be equal to, see the whole square will get cancelled, cos A minus sin A minus cos A. So sine square A upon cos square A. The reason is because minus sine, so whole square if I do it, I will get plus only. So that is equal to tan square A.